Hello everyone. We are starting a free open lecture in our Discord. If you are a viewer and want to ask questions online and get answers, join our lectures. You can find the link to our Discord in our Telegram channel. Today we will talk about quicksort and start with the definition. Quicksort is a sorting algorithm that works on the principle of partitioning. What it is and how it will look, we will discuss later. In short, it divides our array in a certain way, and regarding the division, roughly speaking, by pivot elements, we will learn about this a bit later. It will, you could say, gather it back in reverse order. Purpose. In computer science, programming is used for sorting data. The classic purpose, like all sorting algorithms, is to sort, the principle of the algorithm's operation. Quicksort works as follows. First, a pivot element is chosen in a sequence of numbers. Second, this is the partitioning. All elements are divided into two subarrays. A subarray of elements greater than the pivot and a subarray of elements less than the pivot. You can do the opposite. Then, repeat the first two steps on the subarrays. If the array has two or fewer elements, no recursion. Why no recursion if there are two or fewer elements? As a rule, if we take the pivot element there, then accordingly, the second element will also become the pivot, and therefore they will already be, roughly speaking, sorted in their proper order. If this does not happen, then accordingly, if it has two elements and they are not sorted, then accordingly we apply this algorithm. There are just a few types in our specific algorithm, specifically in our steps. We will use partitioning by the pivot element, even when there are two elements, to ensure they are sorted correctly, and we won't have to check whether the first and second elements are in the correct order. But there are several types of this implementation, so accordingly, this step is written here, and this comment specifically applies. To another type of sorting, I left it to provide variability for our viewers. Step-by-step algorithm. So the first step, we have an array of size 9 which consists of the following elements: 30, 8, 20, 0, 4, 5, 6, 3, 1. Here is another array, not like the ones in the previous sorts. I took one that's a bit larger, so the numbers are quite different. So what is happening here? We choose a pivot element, in this case it's 4, and using it, we divide the array into elements greater and elements less than the pivot. Here we choose 4 and see which elements are less or greater than 4. Less than 4 are 0, 3, 1, and greater than 4 are 5, 6, 20, 8, and 30. This is how we divide the array into elements that are greater and elements that are less. The greater elements are placed here, and the less elements are placed there. In this case, the greater elements are 3, 38, 25, 6, and less than 0, 3, 1. In this case, they are not automatically sorted in any way. What happens next after we have divided everything to the pivot element 4? We will do the same with the left part, and then the same with the right part. Accordingly, we will repeat these steps here until we have pivot elements, meaning all elements of the array become pivots. In the end, all elements of the array will become pivots. Want to become an awesome programmer? Subscribe to our Telegram channel. So here is the second step. We divided the array, and now we take, for example, the left subarray and the right subarray. For the left subarray, we take a pivot element, for example 5, but in this case it will actually be 20. The example just shows taking some element, but in reality, we always take the central element regardless of its value. So greater than it will be 30, and 20 is in the center. So we have 30 greater than it, and less than it are 5, 6, and 8. Thus, we get two more subarrays. If we divide everything relative to 0, 3, 1, we also choose the central element. Greater than it will be 0, 1, and less than it will be empty. We do the same with the array 8, 5, and 6, and the same with the array 0, 1. We choose the central element, and in this case, out of two elements, the central or pivot element will be 0. And accordingly, 1 will be attached, and it will again attach this one as the pivot element. But since the size of the array will be singular, it won't produce anything more there, and so it gets 5.6. And, accordingly, the fourth step, sorting is not needed for 30 anymore. Sorting is not needed for an empty array. Well, 0 is less than 1, so no sorting is needed. In this case, there is a check to see if the first element is less than, the second or not, so we won't have this check here, and accordingly, we will sort everything in the way that is needed. That is, we will still handle it accordingly. Accordingly, in the fifth step, by combining the obtained subarrays and pivot elements, we get the sorted original subarray. How will we collect it? He will first collect along the branch that is smaller, on the right side, and then along the branch that is larger, moving to the left. So it will form an arc. If you draw all of this as a tree, it will look like this. It splits, 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 and so on. Accordingly, the smallest will be on the far right and the largest will be on the far left. And that's how it works. It will gather them from right to left or left to right, and accordingly you will get a sorted array. Want to become an awesome programmer? Subscribe to our Telegram channel